Hey everyone and welcome. Ready to talk Mars.
Always ready to talk Mars.
Today we're doing the deep dive on Martian chemistry. We'll arm you with 5 factoids to impress people at parties.
Should be fun.
Yeah, so we'll be covering the overall chemistry, why it's red, those weird salts they found, perchlorates,
Uh-huh.
and we'll touch on that thin Martian atmosphere everyone's always going on about, and of course water.
The big one, past or present, is it there?
Exactly. So to kick things off, what's Mars even made of? I mean, besides the obvious, like it's a planet.
Right. Well, you kind of hinted at it, the red color. Big clue.
Oh, you mean rust?
Bingo. Iron oxides, basically rust, it's everywhere.
Huh. But there's got to be more to it than just rust, right?
Oh, for sure. You've got those perchlorates, those salts we mentioned, and the atmosphere. Almost all carbon dioxide.
Okay, so iron oxide, like rust, learned about that in school, but Earth doesn't have planet-wide rust, right? Why is Mars different?
Good point. See, on Earth, iron, it kind of gets locked up, in rocks, deep underground like that. But on Mars, billions of years just reacting with oxygen and water makes those rusty plains we see in the pictures.
So it's like the whole planet's been rusting for, like, forever.
Pretty much. We call it oxidation, but, planetary scale.
Wild. So all that rust, does it mess with anything else on Mars?
Definitely does. It's a part of why the water situation is so interesting.
Oh, right, the water. But before we go there, what about those perchlorates? They sound kind of important.
They are, especially if we're thinking about, could anything live there? Or could we even live there?
Okay, perchlorates, break it down for me.
Think of them like frenemies to water. On one hand, they lower the freezing point, so even though Mars is cold, liquid water, maybe.
That's good, right?
Well, yeah, but here's the kicker. They're toxic, not good for humans, so finding them in Martian soil kind of complicates things.
A trade-off, huh? Easy water, but maybe dangerous water. Makes you think about future missions, keeping astronauts safe from that stuff.
Exactly. Imagine having to design spacesuits, habitats, even ways of growing food, all while dealing with toxic salts everywhere.
Tricky. And what about the atmosphere? It's super thin, right? Mostly carbon dioxide. But what does that actually do to the planet?
Ah, the thin atmosphere. Huge reason why Mars is so different from Earth. It's like 100 times thinner than ours. Can't hold heat well at all.
So it gets cold.
Oh yeah, way colder than what we're used to. And the temperature swings. Crazy. From day to night, it's like a roller coaster.
So even if Mars did have liquid water, with that atmosphere, wouldn't it just disappear?
Exactly. Either freeze solid or boil away. Poof. Finding liquid water evidence on Mars is a big deal for that very reason. And that, my friend, is our last Martian chemistry point for today.
Right, the water evidence. Lay it on me. What have they actually found?
Well, there's a bunch of signs that Mars wasn't always a dry, dusty world. We see those dried up riverbeds, lake beds, and of course there's water ice at the poles.
It could make sense.
But there's even some evidence of maybe liquid water flowing underground.
What? Seriously? But how's that possible? With the thin atmosphere and all.
Remember our frenemy, the perchlorates, they could be at work here too, lowering the freezing point again. Maybe water stays liquid underground where it's more protected.
Wow, like a hidden water world. Okay, so just to recap, we've got those iron oxides making everything red.
All right,
Then we have the perchlorates, which are kind of good, kind of bad.
double-edged sword.
Yeah, exactly. And then the super thin atmosphere, causing those crazy temperature swings.
Makes things interesting, that's for sure.
And finally, the water evidence. Ice, past water, and maybe even some liquid stuff hiding underground.
It all paints a pretty fascinating picture.
It does. It really does. And the best part is, we're just getting started.
Back for more Mars talk.
Always up for more Mars. Last time we got the basics, the chemistry that makes Mars so unique.
Right, the ingredients.
Now the big question, could there be life there?
Ah, the big one.
I mean, we talked about the water evidence, but is that enough? What else makes a planet livable?
Good question. Water's key, no doubt. So it's not a guarantee. You need energy sources too. Got to keep those life forms going.
Makes sense.
And stability, the environment can't be going haywire all the time. Plus, you need the right stuff, the building blocks, organic molecules, the carbon-based ones.
Like that's what we're made of, right?
Exactly. It's life as we know it. But thinking about Mars, that thin atmosphere doesn't sound very stable, does it? And doesn't it get less sunlight than us, too?
True. It's like farther away from the sun, right? So less energy to go around.
Exactly. Thin atmosphere means not much protection from space radiation. And those temperature swings, brutal. Less sunlight, less energy for life to use.
So any Martian life, it'd have to be a hardcore. Maybe not like anything we've ever seen.
Totally. Maybe it loves the cold, doesn't mind the thin air. Heck, maybe it even uses those perchlorates somehow.
Oh, right, the perchlorates. We said they're bad for us. But for Martian life, poison, or could they be like food?
Fascinating question. Scientists are still figuring that out. There are extremophiles on Earth. Those are organisms that love extreme conditions. Maybe something similar on Mars?
Wow, life finds a way, huh? Makes you realize maybe we have a limited view of what life is, but how do we even look for it on Mars? Were we talking fossils or what?
Fossils would be a jackpot, but they're super rare, even here. So scientists look for other thoughts, chemical signatures, specific molecules or elements that scream life was here.
Like a chemical fingerprint.
Yep. One example, they found methane in the Martian atmosphere.
Methane. Like cow farts.
Well, kinda. It can come from geological stuff, but also a lot of living things make methane. So finding it on Mars was a big deal. They're still studying where it came from.
So it's like a puzzle, right? Trying to figure out if something's alive millions of miles away.
Big cosmic mystery. And that's where those rovers come in, our little robot detectives on the ground, sniffing out clues in the soil, the rocks, the air.
It's crazy. Those rovers driving around up there sending us data straight out of a movie.
It is pretty cool. Each mission teaches us more, gets us closer to answering those big questions. But finding life on Mars, that's a tough one, even with all our fancy techs.
I bet. What about the future, though? Are we going to send people there someday? What about that whole terraforming idea, making Mars more like Earth?
Big plans, for sure. Human missions to Mars. Not science fiction anymore. A lot of space agencies are working towards that. Terraforming. Still mostly theoretical, but super exciting. Raises a ton of questions, though.
Yeah, like changing a whole planet. Seems kind of bold.
You said it. Terraforming, basically, you'd tweak the atmosphere, the climate, try to make it livable for Earth life. Huge project. You'd need insane technology and a really good understanding of planets.
I can imagine. But wouldn't that, like, mess with Mars? Ethically? I mean, do we have the right to just change a whole other world?
Excellent point. Ethics of terraforming are a big deal. Do we have the right? What are the consequences, intended or not? Gotta talk about that. Scientists, ethicists, everyone, really. It's a global conversation.
Deep stuff. Okay, so we've covered so much. Martian chemistry, searching for life, even humans living there, maybe changing the whole planet. My head is spinning.
And there's more. Next time, we'll dig into some specific discoveries, some real surprises that change how we think about life beyond Earth.
And we're back. Last time on our Mars deep dive, things got pretty intense.
We did cover a lot, from basic chemistry to, could there be life and could we live there? Big questions.
Huge. But now let's get into the nitty-gritty. What are some of the most exciting discoveries, the stuff that's really blown scientists' minds?
Well, one of the biggest game changers, finding organic molecules right there in the Martian soil.
Hold on, organic molecules, those are like the building blocks of life, right? The carbon-based stuff.
Exactly. Not just basic elements, but complex molecules. That's huge.
Does that mean, like, there was life on Mars? For sure.
Not so fast. Organic molecules, they can form without life too, but it's still a major clue. Means the ingredients were there, and maybe still are.
Okay, so not proof, but a good sign. What kind of molecules are we talking about? Anything like super special?
Oh yeah, the Curiosity rover, it found stuff like thiophenes, benzene, toluene. On Earth, those are linked to like coal, oil, even some biological processes.
So it's like the Martian versions of those things. Makes you wonder, did they form the same way? Maybe ancient life on Mars made them. Or some weird Martian geology we don't understand yet.
Exactly. That's why it's so cool. Each discovery, it leads to more questions. We got to keep refining our theories, keep digging deeper, literally.
It's like a puzzle, but on a planet-sized scale. But okay, if we're finding these molecules, what about actual life, like fossils?
Fossils, the holy grail. But Mars, it's been through a lot. Radiation, harsh weather, billions of years of it. Finding fossils would be amazing, but also incredibly lucky.
So even if life was there, the evidence might be gone.
Could be. But scientists are clever. They're coming up with new tech, new ways to search, like looking for specific minerals that often form where there's life.
So even without fossils, we might find clues like chemical fingerprints or something.
You got it. It's all about the detective work. And speaking of which, remember that methane we talked about? In the atmosphere.
Yeah, the maybe cow fart gas? What about it?
Here's the thing. It's not constant. The methane levels, they go up and down, sometimes with the seasons.
Wait, seriously, it's not just there all the time? That's weird. What's causing that? Something going on, like right now, maybe even. Life.
That's what everyone wants to know. Could be geological activity releasing methane from underground, but it could be life, microbes making methane as they do their thing.
So those changes in methane could be like a little signal something's alive down there. Mind blown.
It's one of the biggest mysteries about Mars. Shows us how much we still got to learn. This planet is dynamic, it's changed, and maybe, just maybe, it's hosting life as we speak.
I've got to say, this whole deep dive has been amazing. We started with basic Martian chemistry, then the possibility of life, past and present, of those organic molecules, the changing methane. It's so fascinating.
And it's just the beginning as we explore more with rovers, landers, maybe even sending people there someday. Who knows what we'll find?
It's incredible to think about. I have a feeling everything we've learned today is just the tip of the iceberg when it comes to Mars.
Absolutely. So next time you're at a party and Mars comes up, remember what we talked about. You'll be the resident expert.
And maybe inspire some future Mars explorers. Thanks for joining us on this journey, everyone. Until next time.